The second part of this module 3, we're going to be going more into electrical circuits. And more in particular, we'll be looking at the unit of measurements. We briefly went over it in this first section, but we're going to go a little bit deeper and try to explain more in depth about some of these terms that we have talked about. So the objective, we're going to define current, define voltage, define resistance, and we're going to talk about Ohm's law to solve unknown circuit values. There's no performance test, but in class we will talk about and actually use and work out some problems with Ohm's law. The very first thing we're going to look at is the unit of measurements. There's three main things you need to know. What is voltage, what is current, what is resistance. Those three things tie everything together with electricity. That is the bare bones of how electricity flows. So the ability to charge uh, to do work is called potential. In other words, a potential is the difference between something. So in other words, what's the difference between a positive and a negative? What is the difference? And that is how we measure voltage and we look at voltage is potential difference, the difference between the two. If they both are equal, it cannot do anything. When there's a difference when something is high pressure, something low pressure, that means it can move. When everything is exactly the same, it stands still. So ability to charge to do work is called potential. The electrons is what does the work. We can charge a battery. A battery, we're putting power back into the one of the poles, the negative poles, to have the power source. And it would keep changing back and forth to balance things out. So when a battery is dead, it's basically balance. There's no more stack of electrons on one side of the battery. So ability. So the sum of the electrical charges in the field is the electromotor force. Electromotor force. We call that EMF, or the same thing. So when we hear people say electric motor force or the EMF, all they're talking about the voltage. How much energy, not matter of fact, not energy, how much force do you have? How much stack up electrons do you have built up? Which is expressed in the equations. We just call it E. So when we talk about voltage in electronic formulas, we use the letter E, stand for voltage. So electrical charge is measured in coulombs. In other words, the flow of electrons. So through a wire. And coulombs is this really huge number. I mean, it's quintillion. It's just some really large number, like with 18 zeros behind it. That's how big the number is. So in other words, as the electron is flowing, it's flowing a lot of electrons in a very short time. In 1 second, it's traveling that much. So the electricity flows at a very high speed, some close to the speed of light, which is over 1,000 miles per second. So these coulombs are moving through this. That's why I can heat up a wire if too much current is going through, and can actually cause the wire to melt or burn down or be destroyed. A battery creates an electrical charge by chemically producing free electrons at its negative terminal. So when that chemical reaction happens, it actually causes electrons to build up and to be able to be used. So voltage, we talked about that. Next term we're going to look at is resistance. Resistance. Again, anything that can impede the flow of current. So current flow is measured in amperage and the intensity of the current flow. And in other words, the faster it is moving, more current you are traveling through that wire or through that device. So current flow is measured in amps, and the intensity of the current flow is represented in equations. Of course, when we're using formulas, we use the letter I. I will stand for current. So if you see I, you know, in electricity formulas, it means current. Resistance is the opposition to current flow. It is measured in ohms and represented in equations by the letter R. So in other words, the hotter a wire, the greater its resistance. I don't know what they mean about the hotter the wire. It will have some resistance, actually with very little resistance. Depending on the voltage, it can produce even more heat because the current is flowing through extremely fast. So again, it all depends on the voltage and the resistance, we call the wired. So I'm just adding a little bit more to this because I just read it, and of course it said the hotter the wire, the greater its resistance, which is not really true all the time. It's really based on the voltage going through it too, how much energy you can force through it. Because remember, voltage is the force that pushes through. With very low resistance, you can actually heat up something extremely hot. Now, we're looking at how all this apply. Voltage, resistance, and current. And there's a relationship between the three. If you know what the voltage is, you can determine what the other part is. If you know two things, you can determine the three, because there's a relationship between it. And in this formula here, I can't blow it up, but if you can take a look at it, you can see. Let me use um, my laser. Okay, we got three different formulas. Let's start with this one first in the middle. We can make what we call a pie chart. Basically, it has the three things. We have voltage, we have resistance over here, and we have current over here. So resistance, current, voltage. Voltage will always be at the top. Current, it doesn't matter what side you put it on, but usually we put current first and then resistance. So this is basically the formula. E equals I times R. E equals I times R. This is the division line. So E is always on top. So if you want to know something, if you want to know voltage, put your hands over that E, and what you see is just the I times R. If you want to know what current is, you put your hand over that I, so you can see it's E over R, and vice versa. If you want to know what R is, which is the resistance, it is voltage divided by its current. Again, let's look at these symbols here. When we're looking in a mathematical formula, current, resistance, and voltage, current is I. However, when we represent it as a numerical number, like 120 volts, we use V. If it's 10 ohms, we use the omega symbol. And if it's current, we will just put a capital A for amperage. Again, in formulas, we use I, R, E, and when we're expressing it as a number, and we're writing it down like 120 volts, 10 ohms, and 3 amps of current flow, we represented 3A, capital A, 10 ohms as the omega sign, and then volts would be 120 volts V, capital V. Alrighty, a coulomb is again a large number. And like I say, that is electrons moving in a very short amount of time. So it's a unit of electrical charge equal to 6.25 times 10 to the 18th power. That is, again, a large number. So that's adding 18 zeros. 18 zeros. Big number. Quintillion. So a coulomb is the common unit for the quantity used for a specific the size in a given charge. So here we don't typically talk about coulombs and things. However, so basically we convert that to amps, and which is a smaller number where we can use. So 1 amp is basically equal to 6.25 times 10 to the 18th power. So that so you can say 1 amp. That's a lot easier to say and to use. A joule is a measurement of energy. unit of energy. That's all it is. So you can use it, uh, like I say, if you want to know what the amount of energy, that is a unit of measurement for doing work, some type of work. So again, like I say, work or power or energy is all the same thing, same word. So you want to know what work is always some type of force and some type of movement. Okay, that's energy. You have to have some type of force and some type of movement. So again, if we are looking at some type of form of energy, it always those two things. Always do those two things. So again, what is the force? A Newton is like a gravity force, or it could be a weight force, and on a surface. And a meter is the distance it travel. So again, we can look at many different types of measurements for energy. Ohm's law, again, is a statement of the relationship. Remember I said that voltage, current, and resistance related together. You need to know all three of those to understand how electricity works. Voltage is the force, current is the movement, and resistance what can um, slow it down or to um, uh, cause some type of impedance or opposition of the flow. And a resistor is any device in a circuit that resists the flow of electrons. Here's some questions. A Coulomb or Coulomb law can be used to calculate the blank. And of course, this should come out of your reading, so make sure you read to get a full understanding. So again, Coulomb law can be used to calculate the blank. Is the direction of the current flow, force between two charges, speed of electrons' movement, or loss of current? Is the force between two charges. The amount of force, pressure between the two charges. The negative terminal of a thing that's supposed to be battery contains a large reserve of free electrons. Oops, I just gave it away. Sorry. Which of the following does not have an effect on wire resistance? Is it temperature? Is it the type of power? Is the wire length? And is the material? Or which one of those does not have an effect on a wire resistance? It may surprise you. Is the type of power. Temperature can affect the amount of current of a wire. So in other words, it can affect the resistance. So you heat something up or cool something down, it may be able to slow or increase current flow. So it's the type of power. So it doesn't matter if it's DC or AC power, but it depends on the temperature, the length of the wire, and also the material it's made out of. Next question. Find the applied voltage when the current is 30 amps and the resistance is 4 ohms. Now remember what I said. Now look at the answers. It should be V's, not an ohms. That's a misprint. But it said find the applied voltage. That's what they're asking for. But of course, all the answers saying ohms. So again, we got to use Ohm's law to determine that. And to find out the applied voltage, we need to know two things. We need to know the current and we need to know the resistance. And Ohm's law says voltage equals current times its resistance. So if you multiply those two, you will come up with 120 volts. 120 volts. And this ends the second video for this section.